So the first example we're going to look at here are these three stairs. There's another set of stairs, but we're going to ignore that one for a second. We're going to look at these three sets. They look pretty much identical, right? Same shape, same size, same proportions. Well, where we're going to see the difference is in the actual geometry itself. So let's start with this guy over here. This is something that I see a lot with the student work, is where you have all these edges that are running horizontally to the back. And this isn't great. It's not terrible, but it's not a great way to model this. Remember that every edge is a cost, and so we want to make sure that these edges are serving a purpose. They should either be aiding in silhouette, which they're not because this is completely smooth, or they should be used for vertex blending, which in this example, it wouldn't really work because all the vertexes are just here, so we're not getting anything in here, which means that these guys aren't necessarily needed. Not only that, but this is also not really the best way to model. We're getting a lot of n-gons through here, and while it is true that we could grab these edges here, and when they're triangulated, the engine will probably fix those n-gons, but it's still not an efficient way of doing this, and it's still wasting a lot of edges. So we're gonna take that back and take a look at another example here. And that is this middle guy here. So this is actually the one that I see the most often. Again, we're seeing a lot of these edges that are running through and creating vertexes throughout all of this thing. I mean, this single stairwell is 442 triangles, but the only triangles that are really important for this shape and silhouette are these guys. So 52. So we have a 442 triangle mesh here, but the only important edges that are really affecting our game res and what we're going to see and interact with is just 52. So again, this isn't how we would model something for a game res. I know again that you've been taught to quad everything, but that's not necessary for game res models. It's just a waste of a bunch of geometry that we could use in other instances. So let's take a look at this third example here. This is how you would optimize your mesh for a game engine. I know it might be scary at first to look at with all these triangles, but this is okay. And not only is this okay, this is how this kind of mesh should be optimized. That way we're getting as much bang for our buck as possible. This guy is 106 tries, whereas this guy is 442, and this guy's 154. And this is gonna cause us some issues, or at least has the potential to cause us some issues when it comes to UVing and things like that. So for every one of these, we can use almost or over 4 of these in terms of our geometry cost, which is great. So not only are we really efficient with this, and we can use way more of them, we can now take all these polygons that we have on this side here that we've wasted and use them in other ways to make this mesh even better for the same cost. To show that off, I'll grab this guy again that we had from before and I'll bring him back in. And we'll see here that he's pretty much identical to this guy, but at 158, again, still just around a third the cost of this guy. Not only have I gotten this whole shape in here, but I've now been able to bevel these stairs and get a really nice look here, a really nice looking stair for still a third of this cost, because we were able to take all that geometry out and use it where it's important, where it matters. If you can keep an eye out for optimizations like this, you will end up with much more performant scenes, much more performant meshes, and they'll just look better because you've used the geometry in a very smart and optimized way. Now, in some instances, we won't even need these sides. Like, for example, if you had a set of stairs here that, sat inside of some sort of, I almost call this railing, but that's not what it is, but, inset into something, these stairs really just need to be the stairs. You don't even need to model that stuff. You just want to make sure that whatever is modeled is serving a purpose. It should be there for a purpose. Now, in this example, we don't have any faces here, and this might cause some issues with light bleeding, so it might be okay, or it would definitely be okay to take, a single face here, add another try or two on the back, and another 2 tries on the bottom here and close this off, just to guarantee that you're not going to get any light bleeding. Sure, you're not going to see these faces, you're not going to see these models, but they're serving a purpose. Remember, that's the whole point when you come to modeling, that the face, the vertex, the edge, it should serve a purpose. If the purpose is to occlude light so that you don't get light bleeding, then that's cool. If the edge is inserted in here and we throw a couple of these guys in, you know, to vert blend because you want to be able to vert blend all over this, then that's fine because the purpose is that they are there for vertex blending. That's why they're there. I would still tie this off back here because you're not going to be vertex blending back here, but on here, that's completely fine. You just want to make sure that your geometry is serving a purpose, that it's there for a reason. If it has a reason, then that's fine. If it doesn't have a reason, then you should probably get rid of it. So let's just rapid fire through a couple other examples here. So we have a couple arches here, and I'm going to start from the right here and work my way to the left here. This, again, is not optimized. We have edges that are just running straight off into nothing. They're not serving any silhouette, you know, purpose. This wouldn't be how you would vertex blending because you'd want to be able to vertex blend throughout here. This is just not optimized geometry. Another example I'll see is this. Again, these edges aren't doing anything. These edges in here they're creating the arch, but these edges aren't. So you can just tie them off to the corners and have this mesh. And now we can see this one's 78, this one's 116, and this one's 108. So we're saving, you know, 30 or 40 triangles here, which doesn't seem like a lot, but imagine a scene that has 100 of these. That 30, 40 triangles is now 300 or 400, and that means I can use 6 or 7 more of these in my scene because of how I optimized the geometry here. And I know I've mentioned vertex blending, and this is actually a good example of how we could still get these edges in here for vertex blending, but we can still tie these guys off and be optimized with our geometry and still get the best of both worlds here. Another couple quick little examples here. We got a window. This is all very basic stuff here, but again, from here to here, we go from 26 to 18. Again, these are really basic examples, but just to kind of show you how you can tie this all off, these edges don't have to do this. They don't have to be quadded. We can just pull them off to the corners, and technically these still are quads. Now, going back to kind of the optimization and also with the beveling, we can see this guy here kind of modeled in, you know, that way where you started with a cylinder and extruded offwards and flattened it all out and all that, you know, fun stuff. And we end up with a mesh that's 246. Well, now if we bevel this edge to get this nice smooth look here, which is what we would want. We wouldn't want this to be this hard edge. This ends up coming up to about 416. Well, we can take this same exact mesh, tie everything off to the corners, and now we're down to 370. So again, cutting off 40 some triangles that we can now use in other parts of the geometry, in other areas, to put more meshes in our scene, to use those for other purposes. The cost that we saved here, we can now use that somewhere else in our scene.